Good afternoon to all. I welcome you all to Day 3 International FDP. It's my great pleasure to introduce Professor A. Salama, Dean, Higher Institute of Business and Computer Science, Arish, Egypt. He has completed his PhD in Tanta University, Egypt. He received his doctorate degree in science in mathematics and computer science from CBI International Center for Academic Research, Texas. He is a founder of Neitrosophic topological space and also Neitrosophic crisp theory in mathematics, computer science, and many applications. He is founding member of the first refereed a scientific journal in America and also Neitrosophic sets and systems. He has published 135 research articles in both national and international, and he receives many awards for excellence in research and academic. Today we have a very good eminent person for this international FDP. I welcome you all once again, and also Professor Salama. Thank you.
Fine. Next thing, when a die is thrown on a sand, then it may show either 6 or 5. We cannot come to a conclusion with that. Fine. Now this is what the idea of Neitrosophy about. Next, Professor Salama will be just telling you about more about Neitrosophic sets. Now I'll just come to what are the application it is having for a Neitrosophic set. It is applied in many different subjects like psychology, sociology, civil engineering, information technology, and also in linguistics. Similarly, it is also applied in mathematics too, in various branches of mathematics like probability, calculus, algebra, topology, graph theory, decision making, and many more. I have been given you glimpse about the application of Neitrosophic sets. Yeah, this is what I'm just taking only 5 minutes time. Only last one is you can just go to the website of Professor Salama. This is the home page. I'll just post it in the chat box too. You can just go visit his web page, and also journal link also given. You can see this now. Click on the web page. At a web page, click on. Okay, you can see the web page if you. Yeah, this is the web page of Professor Salama. Here we can see all the works, everything. So these are the works related to Neitrosophic set theory in the web page of Laurentine. Then the journal he has, that also we can visualize. So anybody interested in this topic, it is a well good topic. You can just work in it. This is the journal web page. So this is a Scopus Index journal, and it is also cited in Web of Science. Okay, thank you so much for patient listening. Now we'll just have the introduction about Professor Salama by Ms. Kartika.
Good afternoon to all. I welcome you all to Day 3 International FDP. It's my great pleasure to introduce Professor A. Salama, Dean, Higher Institute of Business and Computer Science, Arish, Egypt. He has completed his PhD in Tanta University, Egypt. He received his doctorate degree in science in mathematics and computer science from CBI International Center for Academic Research, Texas. He is a founder of Neitrosofic topological space and also Neitrosofic crisp theory in mathematics, computer science, and many applications. He is founding member of the first refereed a scientific journal in America and also Neitrosofic sets and systems. He has published 135 research articles in both national and international, and he receives many awards for excellence in research and academic. Today we have a very good eminent person for this.
Dear participants, for any questions, please mail Dr. Salama, and the mail ID I'll just post in the chat box, because due to some net problem he has just left. Due to some network issue, he could not come again. I'll just post his mail ID. This is the mail ID of Dr. Salama. You can just post the things. Feedback link, I'll post it now.
عرفت كيفاش يدير البارو.
Good evening to all. We come to end of this session. So on behalf of our department, so I give vote of thanks. So Dr. Salama explained about Neitrosofic sets. Neitrosofic sets and applications of Neitrosofic sets. Applications in the area of Neitrosofic database, image processing, GIS topology, etc. So these concepts are very interesting. He explained the concept interestingly, and I think these applications are new to us. So thank you, sir. Thank you for giving this type of concepts to us. And also, he explained about the implementation of Neitrosofic sets using OOPS concept. And this is also a very interesting one. Thank you, sir. Next one, I thank the participants for the entire session, for their patience listening. Thank you all. I thank our department people for their support. And also I should thank our convener, Dr. M. Parimala, to conduct this type of FTBs. And I thank our management also for supporting us to conduct this type of FTPs. Thank you one and all. And the feedback session, feedback link is posted in the chat box, and you can send your feedback. And tomorrow's session, the same time from 2:30 to 3:30. And you can access the same link before 15 minutes tomorrow. Thank you one and all.
If you want to share anything, you can just share it. Yeah.
Yes, sir.
ما عرفتش كيفاش ندير.
Professor Said Rami, what, sir, you can just tell me. Sir, if you want to say something, you can tell, sir. Professor?
Hi buddy, you hear me?
Yeah, sir, we can hear.
Yes, I hope you hear me without noise. I hope to thanks Dr. Salama for the presentation and the information on here nitrosofic recipe set. For the researcher need more information, they can refer to the website of NSS and EGNS. And many articles and books on nitrosofic are available on website. For the next day, I mean tomorrow, Dr. Adesina and Madeline will give us other concepts related to nitrosofic group theory, nitrosofic structure theory, ideal polygroup brain theory. I also thank you, Barry, for the organization. I hope that Dr. Salama share his exploitable slide to nitrosofic logic. And finally, if possible, that Dr. Salama explain briefly the next last slide on nitrosofic logic gates. Thanks, Dr. Salama.
Thank you, Professor. Thank you for your kind words. Thank you, everyone. Now let us wind up the session. Meet you tomorrow. Thank you.
Philosophic philosophy. So I would not want to, deal with all that because the Professor Salama yesterday, of course, now.
Hello everyone. Hope you're feeling good. The researchers, ladies and gentlemen, greeting from the depth of sentimental. I don't know where to start. I hope the words help me. The words and the phrases dwindle, but I will try as best I can and hoping that the more satisfactory. I am glad to be with you in this scientific meeting and the wonderful staff in the world. My name is Ahmed Salama, Professor of Mathematics and Computer Science, Faculty of Science, Port Said University, and Dean of the Higher Institute of Business and Computer Science, Arish, Egypt. And today I will talk in my presentation about Neitrosofic, mathematics and computer science. I hope you will like it. And real life problems The data associated are often imprecise or non-deterministic. Since the world is full of indeterminacy, the Neitrosofic found their place into contemporary research. Indeterminacy is different from randomness. Indeterminacy can be caused by physical space, materials, and type of construction, by item involved in the space, or by other factors. Neitrosofic has been introduced by Samarnadaka as a new branch of philosophy. In 1995, Samarnadaki defined the notion of Neitrosofic sets, which is a generalization of fuzzy sets and deterministic fuzzy set. Samarnadaka first introduced the notion Neitrosofic set by fusing a three-component set and the non-standard analysis. A Neitrosofic set consists of three functions where every function's value is a real standard or non-standard subset of the non-standard unit interval. In 2015, Slamma and Samarnadaki were introduced the Neitrosofic crisp set theory and many applications in mathematics, computer science, information system. Neitrosofic approaches are suitable to modeling problems with uncertainty, indeterminacy, and incomplete information, in which human knowledge is necessary and human evaluation is needed. Neitrosofic set is capable of dealing with uncertainty, indeterminacy, and incomplete information. Neitrosofic set approaches are suitable to modeling problems with uncertainty and indeterminacy information, in which human knowledge is necessary. Neitrosofic set means development many applications. Neitrosofic set, Neitrosofic logic, Neitrosofic probability, Neitrosofic statistics, Neitrosofic measures, Neitrosofic calculus, and so on are gaining significant attention in solving many real life problems that involve uncertainty, impreciseness, incompleteness, and indeterminacy. In the past years, the fields of Neitrosofics have been extended and applied various fields such as artificial intelligence, data mining, soft computing, decision making in incomplete indeterminate information system, image processing, medical, biomedical engineering, economics, social science, and practical achievements. The first example, or the first application, the Neitrosofic concept of Neitrosofic topological, the concept of Neitrosofic topological space. In 2010, I am introduced the Neitrosofic topological space by using the nitrosophik, two types of nitrosophik topological space. The first type, nitrosophik topological space from nitrosophik fuzzy set, and second type, nitrosophik topological space by using nitrosophik crisp set, nitrosophik crisp topological space. Some nitrosophik concepts have been investigated by me we was developed an Excel package to be utilized for calculating nitrosophik data and analyze them by using object-oriented programming techniques and concepts of they may apply to the design and development a new framework to implement nitrosophik data operation. Since then, many authors have studied various aspects of nitrosophik set from different points of view. For example, in order to apply the nitrosophik ideology, we obtained a good applications in cluster analysis and image processing by using nitrosophik domain. Promi and Rafif al-Habib and Florentine Samarnadaki introduced many concepts of nitrosophik applications. The concepts of rough nitrosophik sets, we introduced the nitrosophik, for example, the nitrosophik, rough nitrosophik sets. The rough nitrosophik sets handled incomplete and indeterminate. Handled incomplete and indeterminate information and studied some operations and their properties. The theory of classical statistics assumes a crisp, certain and clear observation parameters in technology applications. However, in such technology applications, due to their complex function, it may not be possible to obtain clear or crisp values of certain parameters, so there is a chance of obtaining indeterminate, imprecise, and incomplete parameters. Nitrosophik statistics can be applied, nitrosophik statistics applied, which is the generalization of the classical statistic. This is reduced to classical statistics when new parameters are found to be indeterminate, imprecise, or incomplete in actual practice. The Nitrosophik Science International Association was established in 1999 with its headquarters at the University of New Mexico, United States. Nitrosophik Science Association, for the betterment of science, identifies and supports eminent nitrosophics researchers. The association shall seek cooperation with other associations and organizations, sharing the same objective and being active in the field of nitrosophic theories and applications. The association primary aim is promote science, especially nitrosophik theories and their applications. Our aim of our association is to support original research which is not necessarily restricted to ideal subject of nitrosophik methods currently receiving emphasis. In 2015, nitrosophik crisp theory, the first foundation of the theory were laid out in the book that was preceded by many research papers with participation with Professor Florentin Samarnedek. The Nitrosophic Sets and System journals in 2013. I was proposed to Florentin Samarnedek to publish the first scientific journal in the field of nitrosophic. In 2016, the Encyclopedia Nitrosophic Researchers, the first volume of this encyclopedia, the first volume of the Encyclopedia Nitrosophic Researchers, added from materials offered by the authors who responded to the editor's invitation. The 78 authors are listed in the first volume. The volume contains the introduction. The volume contains the introductions, a short history of nitrosophics, together with links to the main papers and books. Now, with the presentation of some important definitions, nitrosophic techniques both combines all certainty and uncertainty data. Nitrosophic technique contains certainty and uncertainty. Nitrosophic is the latest developments in the certainty and uncertainty data processing. The nitrosophic both combines all nitrosophic certainty and all certainty and uncertainty data. What is the nitrosophic set? From the definition, from nitrosophy to nitrosophic set. Nitrosophy, a new branch of philosophy which studies the origin, nature, and scope of neutralities, as well as their intersection with different identical spectra. Nitrosophic logic are generalization of the fuzzy logic and the instantistic fuzzy logic. Nitrosophic crisp logic are generalization of the crisp and Einsteinistic crisp logic. Neitrosofic logic proposition has 3 degrees: trace degree, indeterminacy, and velocity, where T, I, and F are standard or non-standard subset of the unit interval. What is the Neitrosofic fuzzy set? Neitrosofic fuzzy set, let X be a non-empty fixed set. A Neitrosofic set from fuzzy is an object having the form 3 functions. That 3 functions: A, mu, alpha, and beta. Mu, alpha, beta, where and which represent the degree of membership functions: mu, namely mu, and determinacy, namely alpha, the non-membership functions beta of x. The sum of 3 functions degree, the sum of 3 degrees from 0 lies from 0 to 3. What is the Neitrosofic crisp set? The first, Neitrosofic leads to Neitrosofic fuzzy set leads to Neitrosofic crisp set. The Neitrosofic crisp set, let X be a non-empty fixed set, then we can define the triple of subsets of the universal set X. This triple A1, A2, and A3. The Neitrosofic crisp set having the form A consists of 3 subsets for the universal set X: A1, A3. Neitrosofic crisp set, the object have the form A1, A2, A3 can be classified into 3 different classes as follows. The first class, A, is said to be Neitrosofic crisp set, or the class number 1, or the type 1 Neitrosofic crisp set, class 1, is satisfied A1 intersection A2 equals phi, A1 intersection A2 phi, A1 and intersection A3 equals phi, and the A1 A2 intersection A3 equals phi. This Neitrosofic crisp set with class or with type. Type 2, A is said to be Neitrosofic crisp set with type 2 or class 2. Neitrosofic crisp set class 2 if satisfied all A1 intersection A2, A1 with A3, A2 with A3, the intersection between A1, A2, A3 equals phi, and the union of A1, the first component, second component, and third component equal the universal set X. The class Neitrosofic crisp set class 3. A is said to be Neitrosofic crisp set of class 3 if satisfies all intersection for the three components equals 5, and all the union of all three components equal the universal set X. This nitrosophik 3. Nitrosophik crisp set class 1, nitrosophik crisp set class 1, nitrosophik crisp set class 2, nitrosophik crisp set class 3. These new types of nitrosophik crisp sets named star nitrosophik crisp set. Star nitrosophik crisp set is another type retract nitrosophik crisp set. Nitrosophik crisp set contains all types of nitrosophik crisp set with the class 1, class 2, class 3, star nitrosophik crisp set, and the retract nitrosophik crisp. A star nitrosophik crisp set the nitrosophik crisp set A1, A2, and the structure or the form A1, A2, and A3 of the non-empty fixed set X. Then the star nitrosophik crisp set is A1 star, A star equals A1 star, A2 star, A3 star, where A1 stars equals A1 intersection the complement of union of A2 and A3. A2 stars equals the A2 intersection the complement of the union of A1 and A3, and the A3 star equal the third component A3 intersection the complement of A1 union A2. Star nitrosophik crisp set A1, A3, A1, A2, A3. What is the retract nitrosophik crisp set? The nitrosophik crisp set, the retract nitrosophik crisp set is a star nitrosophik crisp set of category 1. In other words, for any nitrosophik crisp set, if the three components A1, A2, and A3 satisfy the condition A1, AI intersection AG not equals 5, for all I equals 1, 2, and 3. The retracted nitrosophik crisp set the structure the symbol of A retract equals the triple subsets A1 retract, A2 retract, and A3 retracts, where A1 retract equals A1 intersection the complement of A2 union A3, A2 retract equals A2 intersection complement A1 union A3, and the third component A3 retract equals the A3 intersection the complement of A1 union A2. From operations on the nitrosophik of the retract nitrosophik sets and the star nitrosophik sets. Operation the complement of retract nitrosophik crisp set may be defined as the following. The retract nitrosophik intersection of the retract set A and the retract set B is defined by A1 retract intersection B1 retract, A2 retract intersection B2 retract, A3 retract intersection B3 retract. The retract nitrosophik union of the third operation is defined by A retract union B retract. The following relation. Operation A1 retract union B1 retract, and second component A2 retract union B2 retract, and third component A3 retract union B3 retract. The retract nitrosophik difference. All operations crisp set. Then we have crisp set, interstonistic crisp set. Crisp set leads in stonistic crisp set. Nitrosophik crisp set implies to or leads to star nitrosophik crisp. A star nitrosophik crisp leads to retract nitrosophik crisp set. Retract nitrosophik crisp sets as a generalization of all crisp sets. The relation between crisp set and nitrosophik crisp set, fuzzy set, nitrosophik crisp set, and nitrosophik fuzzy set. Nitrosophik crisp set inside the nitrosophik crisp set. Nitrosophik crisp set contains all types of crisp set, class 1, class 2, class 3, and nitrosophik crisp set. Nitrosophik crisp set inside the stonistic crisp set, inside the stonistic fuzzy set, inside the fuzzy set, nitrosophik fuzzy sets as a generalization of fuzzy set in a stonistic fuzzy set in a stonistic nitrosophik crisp and nitrosophik crisp set. From problems to nitrosophik decision, problem mathematics is used to transform the problem into data and then to process. We get information, organize information that leads to knowledge, then wisdom and optimal decision making. Decision making problem transformed into nitrosophik data by using mathematics. When processing the nitrosophik data leads to nitrosophik information, leads to knowledge, implies to nitrosophik decision, wisdom, and optimal decision. From crisp logic to computer science. From crisp logic to fuzzy logic, nitrosophik logic. Nitrosophik logic contains all types of logic. Nitrosophik logic as a generalization of fuzzy logic, crisp logic. From crisp logic to crisp mathematics leads to crisp statistics. Crisp mathematics implies to fuzzy mathematics, implies to nitrosophik mathematics. crisp statistics leads to fuzzy statistics, leads to neitrosofic statistics. From crisp logic to computer science and information technology by using neitrosofic techniques. Some applications. What is the neitrosofic information system? The principle of neitrosofic computing is useful to software implementation for a large plethora of applications. What is the neitrosofic information system? And neitrosofic information system consists of three variables A, R, and B. The neitrosofic system equation A circle R equals B. A, the neitrosofic inputs or neitrosofic data. R is the neitrosofic system, and neitrosofic outputs. B, neitrosofic information. A circle R equals B. From crisp statistics to neitrosofic statistics and Excel, SPSS or Excel package for with neitrosofic Excel with neitrosofic package and transform to SPSS. Crisp probability leads to fuzzy probability, leads to instantaneous fuzzy probability, leads to neitrosofic fuzzy probability. From the crisp statistics to neitrosofic fuzzy statistics. Neitrosofic fuzzy statistics is a generalization of all statistics, crisp, fuzzy, and statistic. This is implementing neitrosofic operation using object-oriented programming. Neitrosofic operation classes, tools and techniques, object-oriented programming, C# language.net framework, Visual Studio Net, and Excel. From crisp data to neitrosofic data. This graph represents the neitrosofic component. Crisp data A is the crisp data. B, C, D, all B, C, D, E, B, C, D. B represent the membership functions for the crisp data 82.8. C, indeterminacy. D, non-membership function. Neitrosofic package interface. The cell contains 3 degrees, 0.3, 0.4, 0.5, and the set neitrosofic set A and neitrosofic set B. The intersection may be defined as 3 types. Number 1, the first type for intersection between 2 neitrosofic sets. The first type of intersection. The second type of intersection. The third type of intersection. Neitrosofic package interface for neitrosofic for intersection. Neitrosofic package interface for the complement. 3 types of complement for between 2 neitrosofic sets. The complement of neitrosofic sets may be defined with 3 types. The first type, second type, third type. The one cell in Excel contains 3 points or 3 values degree: membership, non-membership, and indeterminacy. This, for example, neitrosofic chart by using the program. Neitrosofic package union chart. Neitrosofic package data structure, computer science data structure, neitrosofic crisp set, probability of neitrosofic crisp set, neitrosofic set, correlation of neitrosofic data, neitrosofic regression, neitrosofic topology, neitrosofic ideals, neitrosofic filters, neitrosofic database, neitrosofic image processing, neitrosofic security, neitrosofic GIS topology, implementing neitrosofic data, image retrieval using neitrosofic domain, enhancing image using neitrosofic domain. Some applications, another application, crisp e-learning, fuzzy e-learning, e-learning in stochastic fuzzy leads to e-learning neitrosofic. E-learning neitrosofic as a generalization of all types of e-learning. From crisp security to fuzzy security and stochastic fuzzy security to neitrosofic fuzzy security. Neitrosofic fuzzy security as a generalization of all types of security. Neitrosofic image processing as a generalization of all types of image processing. Neitrosofic database as a generalization of all types of database. Neitrosofic GIS topology as a generalization for all GIS types of GIS topology. Crisp mathematical morphology. Neitrosofic mathematical morphology as a generalization of all from topology to neitrosofic topology. Neitrosofic crisp topology, the relation between neitrosofic and second neitrosofic fuzzy topology. From crisp topology to stochastic crisp topology, neitrosofic crisp topology. From neitrosofic topology, neitrosofic crisp topology to neitrosofic topology. Neitrosofic topology as a generalization of some filters. Neitrosofic filters contains all types of filters. Neitrosofic ideals contains all types of ideals. Neitrosofic GIS topology types of topology. Neitrosofic approach for mathematical morphology. Mathematical morphology is also the foundation of the morphological image processing, which consists of a set of operators that transform image according to the above characterization. Neitrosofic mathematical morphology applications in image processing, applying neitrosofic mathematics morphology in image processing. From image to neitrosofic domain. Neitrosofic domain for image, a value represented the membership functions mu and indeterminacy and non-indeterminacy. A value represented of the force value is called his tensor measure by of x. This the fourth component for nitrosophik, a new component for nitrosophik domain. Pi of x equal 3 minus the sum of all degree function. From the grayscale image, by using nitrosophik crisp component, this is the nitrosophik crisp component and star nitrosophik crisp component for image, the retraced component for the grayscale image. From the original grayscale image and binary to the nitrosophik crisp to the nitrosophik domain. A new structure for logic gates using nitrosophik techniques. Nitrosophik logic gates. This example. Nitrosophik logic gate, the trace table of nitrosophik and gates. Nitrosophik logic gates, design a nitrosophik AND gate. Another application, nitrosophik logic gates. Thank you for your kind attention. I hope you have liked the topic today. Goodbye.